Hello, this is Mrs. Boots, and this is our lesson on quadratic inequalities. So the first thing we have is 4 equations. Okay, so we could kind of group these equations. The first 2 both have a less than symbol. The second 2 both have greater than symbols. I could also group it by the signs. Notice the second and the fourth one both have a negative in front of the x squared. That means my parabola is going down. The first and third ones both have the parabola going up. Okay, so let's look at my up parabolas. First one, my parabola is up. So I know it can be the first one or the third one. It's not going to be the second or fourth. I believe we have these labeled A, B, C, and D. Okay, so let's look at it. Where is the shading? Okay, so look at which part of the y-axis is shaded. Is it the part at the top or the part at the bottom? Well, this is the part at the top. Okay, the part at the top tells me it has to be greater than or equal to a positive x squared. Which one is greater than or equal to? That would be letter C. All right, easy enough. Now, let's look at this one. This graph also has a positive x squared. Write that down. We know it's a positive x squared, but which part of the y-axis is shaded? Is it the top part or the bottom part? It's the bottom. The bottom is less than. So that would be letter A. All right? Now I have a parabola going down. A negative parabola means a negative x squared. So I know it can only be B or D. Now which part of the y-axis is shaded? The top or the bottom? The bottom is shaded, so it has to be less than equal to. Wow, yes, this is answer B. Now let's look at the last one. Parabola is facing down. It's a negative x squared. Where's the shading? At the top of the y-axis or the bottom? It's at the top. The top is greater, so this would be greater than equal to, and that is letter. Oh, I wrote the symbol wrong. That is letter D. Okay? Now some of you may be looking and saying, but the top 2, the shading's inside the parabola, and the bottom 2, the shading's outside the parabola. If you don't trust it, plug in a test point. Okay? Always plug in a test point. So if you pick the point up here on the axis, that's inside the shaded region, right? We could say that's 0, 2. Okay? So if I plug in 0, 2, what would I get? So we said that's y greater. So 2 is greater than or equal to 0 squared. Is that true? Yes. 2 is greater than or equal to 0. Awesome. Now for this one, I want it to be true, right? I'm double checking. So I'm going to pick a point out here. Again, I'm going to pick a 2. So this one's 2, 0. Plug it in. 0 is less than or equal to 2 squared. Is that true? Yes, it is. Next one. Find a point, plug it in. Point in the shaded region, negative 2. So plug it in, I get 0 less than or equal to a negative of negative 2 squared. Negative 2 squared is still positive 4. So is 0 less than or equal to negative 4 because there's a negative out front? Yes, it is. All 4 of them check. Let's pick the point 0, 2. So is 2 greater than or equal to negative 0 squared? Yes. Okay? Every single time, we simply plug in points to check. Anytime you're unsure, you can do that. Let's work some examples. Example 1. Now notice the first 3 examples have a y in them. So I have an equation or a function, y inequality with a quadratic, all three of them. These three I'm going to use a graph. Anytime I have y and I don't know, I use a graph. Examples 4 through 6 all have numeric values instead of a y. So for those problems, I'm going to look at the table in my calculator instead of the graph. All right, now our graphs don't have to be precise. We're more concerned about where are we shading. What kinds of line are we drawing and where are we shading? Okay, so example 1, I have this beautiful quadratic and we could factor it or we can look on the table and we would find out that we have roots at -1 and +3. And I know my quadratic is going to face up. So I'm just going to draw my quadratic in. Now, I drew it as a solid line. Is it supposed to be solid? Yes. I have a line underneath. It's supposed to be solid. Now we have to figure out where to shade. Well, I have a greater than symbol. Where is it greater? Where the y's are at the top. So I would shade on the inside. If you want to, you could also pick a point to check. 0, 0, and 1, 1 are the easiest points to check. So let's pick 0, 0. So I'm going to plug in a 0 for y, greater than equal to 0 minus 0 minus 3. So is 0 greater than or equal to -3? Yes. So I should shade where the 0, 0 is at. So that's inside my quadratic. That one is correct. That's all we have to do on these. Now, let's look at the second one. Where would my roots be? Well, I could factor this into x plus 2, x minus 2. That gives me my two roots. 1, 2, 1, 2. -2, +2. I could have recognized that that was a parent function format that's moved down 4. Either way. Now I drew it in as a solid just because I got ahead of myself. Is it supposed to be a solid line? No, it's supposed to be dashed. So I'm going to come in and erase, make it dashed. Okay? Doesn't matter if you color over it or if you erase. Either way. Now let's see which way we're supposed to shade. It's a less than. Less than. Where's less than? Less than's at the bottom. So I should shade outside. Now I can still plug in 0, 0. But in this case, am I expecting to get a true answer? No. I'm expecting to get a false. So let's check it out. 0, 0. Go back to the original equation, or inequality. I would have 0 less than equal to 0 squared minus 4. Is 0 less than -4? No, it's not. So I would not shade at 0, 0. That means my graph is correct. I shade in the other area. It gets a little tricky. Example 3. Always start with factoring and figure out your basic picture. I'm going to pull a GCF out. So I get -2x times x minus 4. Okay. So when I set -2x equal to 0, I get 0. So I know that one of my roots is at 0. X minus 4 equals to 0. Solve it, you get a 4. So there's my other root. It's a negative in front, so it's facing down. I know, it's kind of lopsided, isn't it? Now, should it be solid or dashed? It should have been dashed. That's an inequality without an equal sign. So I'm going to come in and make it dashed. Dash, dash, dash. Some students like to use the highlighter and put dashes over top. It doesn't matter which way you do it. Okay? Now, we're shading greater than. Where is the y greater? Is it at the top or the bottom? It's at the top. So y is at the top. That's where it's greater. That's where we're shading. The top happens to be outside of my parabola. Now, since 0, 0 is on my curve, I cannot use that point. I have to pick another one. So I'm going to pick 0, 1. Okay, let's plug in 0, 1. So the y value is 1. So 1 greater than negative 2 times 0 plus 8 times 0. Well, those are both 0. So is 1 greater than 0? Yes. That means I shaded in the correct spot. This is how I do it if my inequality is a function. It has the y values. Now let's look and see what we would do if it has a number. This is more like what we do in real life. And we're going to get to some word problems here in a minute. So I would plug this equation into y1 in my calculator. Or I could simply create a table by plugging in values for x and get the y. So plug in 0 first. That's always the easiest one. Y value is 2. And I plug in 1, I get negative 1. And for 2, I get 0. So that kind of gives me a picture. It's going down and coming back up. Now I want to know, where is it greater than 0? Well, somewhere in between, right in here, it went underneath. So I could factor it and find out. If I factor it, I'd get a 2x with a 1 and an x with a 2. Because this is 2, 0. So I know I have an x with a 2. So that gives me a negative 1/2. So at negative 1/2, positive 1/2. At positive 1/2, I get a 0. Okay? That's my other root. That helps me out. So now we want to know, where is it greater than 0? So look at your table. It's greater than 0 from 1/2 towards the negative infinity, and from 2 towards positive infinity, right? So now we just write that out. It's just like a domain. We have negative infinity to 1/2, and then we do a 2 to positive infinity. Easy enough. This is how we work with the real worlds. A little bit. We're going to get to some others. Let's do a table for the next example, example 5. Okay? X's and Y's. Let's start with negative 1 on this one, just so we get a clear picture. So at negative 1, our value is 15. Okay? At 0, we get 4. For 1, I got a negative 3. Let's scroll down. For 4, I get 0. And then one more point. We'll do 5, 9. Now, in this equation, or inequality, they're asking us for what? Where is it less than 0? Less than 0. So, it's less than 0 right in here. Right? From 0 to 4, it is less than 0. Well, where is it equal to 0? We would have to factor it or use quadratic formula, and your guess is right. It's at 1/2, 0. Okay? That's where my other root's at. So now let's put it in. I would go from 1/2 to 4. We would have parentheses because we do not include where it's actually equal to 0. It's just from 1/2 to 4. That's where it's less than 0. Okay? Example 6. Doing our table. Okay? I'm going to start at 0 for this table. So plug it into y1. And I have 0, 0, 1, 16. 3 is 36. I'm kind of skipping a little bit. 4 is 40. I'm going to skip down to 6. That's at 36. And 9 is at 0. Okay, so I know I skipped a few numbers in there. That's just so we don't have to write the whole table. If you want, you can put a little dot, 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 so that you know you skipped some values in there. So what do we want to know from our table? We want to know where our function is greater than 36. So greater than or equal to 36. I look at my y values, and my 36s are right in here. That's why I skipped to those values. So it's because I knew what I was looking for. What x values correspond to those y's? Well, it starts at 3 and goes to 6. So my solution, my answer, would be from 3 to 6 with square brackets because it's equal to. If we don't have the equal to, we use parentheses. If we have the equal to, we use the brackets, which means I should have used brackets on example 4. So anytime I have just an inequality with a y, I solve it with a graph. I'm shading it. This is like our systems of linear inequalities. If I have an inequality equal to a value, I want to know a domain. Where is that true? And the domain is my answer. I can get that from a graph, or I can get it from the table. Most people prefer the table. Let's look at some word problem examples. Example 7. A golf ball is hit from ground level at an initial velocity of 80 feet per second. How many seconds before the ball hits the ground? Well, we have to start by writing our equation. It's actually really easy. The equation comes from physics. The negative 1/2 g x squared plus the velocity times x plus h, our height. Now remember, g stands for gravity, and they told you gravity was 32.2. For these problems, we're just going to round to 32, and when you take half of 32, you get 16, okay? So my equation is going to be y equals negative 16x squared plus my velocity. What was the velocity? 80. Plus 80x plus my initial height. What was my height? 0. Well, we don't have to write that. So this is my equation. Now we're going to put that in our calculator into y1. And we're going to look at our table. So my table for my x's and y's. Obviously, we still can't have negative time. So we're going to start with 0. So I can do 0, I could do 1, I could do all of them, but I'm just going to scroll down because they want to know where did it land. And I see 5, 0. So it landed after 5 seconds. And that would be my answer. Super easy. You could trace the graph on the graph screen, or you can look at the table. Okay? Next example. We have a football kicked from ground level. It has an initial velocity of 48 feet per second. How long is it going to be in the air? Same equation. Y equals negative 16x squared. Now, how many feet per second was it? 48. So 48x. Now, what was the height of the ball when it was kicked? Ground. That's 0. So I don't have to put it. So I'm going to put this in my calculator into y1. Now, would I have to use different gravity if I was on the moon? Yes, of course. So this depends on which planet we're on. Thankfully, we only play football on Earth. We don't have the intergalactic league yet. Okay, so we do our table of x's and y's. And I see 0 is 0 and 3 is 0. So how long is it in the air? It's in the air from 0 to 3. So that's a total of 3 seconds in the air. Okay? It turns out it's the same as if it was landing. All right? Now let's look at 9 and 10. These two examples, they give us an equation, and it's not dealing with gravity. It's dealing with profit. And there are businesses who do model their profits using different equations. In this case, it would be a quadratic. So we have the monthly profit of a nice small business doing bicycle helmets. Good business to be in. Okay, they give us the equation, and then they ask us Where's the profit at least 6,000? Okay, so I should write this has to be bigger than or equal to 6,000. Okay, so I'm going to plug my equation into y1. I am then going to look at my table. I'm going to scroll down, look at my x's and my y's. As I scroll down, I notice that 19, at x equals 19, I have 6 and some numbers. That's above 6,000. If I keep scrolling, I have 56, 6 and some numbers. In between there, the numbers are all bigger than 6,000. So, where is my profit greater than 6,000? Between 19 and 56. Now, they're not equal to 6,000 at those values, so we would leave it as parentheses. We would not do that as square brackets, okay? Now, let's look at number 14. We have a business that does tours. They model their profit with this quadratic equation. And they want to know how many people they have to sign up so they don't have to reschedule. But that means their profit cannot be less than, what was the amount? 7,500. So where is my profit less than 7,500? So we have to look at our table. Again, scroll down. Don't write them all down. I'm going to scroll, obviously at 0. It's at negative 5,000. That's no profit. You're losing money, okay? So now I scroll down and I see at 13 it breaks, and it's 7,025. Okay? So anything from 0 to 13, I'm not making a profit. Because at 14, I'm at 7,600, right? So I have to have at least 14 people. That would be my answer. Now you say, Mrs. Boots, what about the other side? Because your quadratic is going to come up and go back down. You're right. The other end, you could do it, but they didn't ask for that. They asked how many was at least needed to be signed up. They don't care if you have too many people. That's when they schedule a separate tour. This concludes all of our examples for quadratic inequalities.